Good day everyone and welcome to another video on our MATLAB tutorial from Federal University of Technology, Mina. And today we're going to be looking at array and indexing. From our previous videos, we did a little briefing on what matrices are. I remember saying that you can take matrix, you can picture a grid, or when I mean grid, I mean let's say a 4 by 4 grid, a 3 by 2 grid, and a perfect example could be like a chessboard, right? So that's an example of what of matrix. Matrices, contains vectors. Okay, we have vectors and we have scalars, yeah, and matrices contains rows and columns. So every matrix there's always a row and a column. Otherwise, it will be called a matrix. So arrays, in MATLAB stores numbers in arrays, and arrays can be scalars, which is a one by one, or vectors, which is a one by n or 8 by 1 matrix. So most operations in MATLAB work best with matrices and vectors. So when we talk about first of all a row vector has an element in a single row separated by spaces or comma. So that's a row vector. So let's say u1 to be equal to, and then how do you start? The first thing first when you are dealing with vectors, rows, matches, and so on is to know your correct. We should start with the correct bracket, which is this one. So before I do that, I need to clear our workspace. So and our command window. So let me quickly do that here. Remember from our last video, we talked about to clear our workspace. R all the small letters. Clear. Then we run that. Good. So v1. So remember we're trying to get a row vector of this could be 1, 2, 3, 4, 5. This is a row vector. So this is correctly done, and you can also do something like this. v1 is actually equal to. So first of all, use your correct bracket, which is a square bracket. This is 1, 2, 3, 4, 5. And then when you run this, you actually get a row vector. If either of these will actually work okay, that use a space to separate your your the digits in between, or you actually use a comma. So now how do we go about a column vector? So let me say this is column 1. This will be equal to, so this is going to be 1, a semicolon, 2, semicolon, 3, semicolon, 4, semicolon, then 5. And then if we run this, we're going to have a column vector. This is a very simple explanation. So whenever you see a row, we're talking about the horizontal aspect. We talk about the column, it's the vertical aspect. So there are other ways in which you can define, rows and columns instead of doing it manually. So now we're going to be going into, little bit into some functions which are going to be seeing now. But before that, let's use a different approach. So let's say v2 for example is equal to 1 colon. Okay, so this is 1 colon. I'm using a colon right here, and then 2. I hope you guys can see my screen. Okay, so this is 1. I used a colon 2. What should this output now? What can this actually output? So let's run this and see. Good. Run. This simply means what MATLAB interprets as this. Let's do it. Our command window. We will be needing it anytime soon. This simply means I want you to give me numbers from 1 to 2. So what if I do to what? To 20. So this is going to be a 1 by 20 matrix. Yes, as you have here, a 1 by 20 matrix. So this is going to give me numbers from 1 to what? To 20. So that is a very good way to get a vector matrix. So what if I want there to be space in between? I want you to be 1 to 20, but I want it to be like maybe evenly spaced, something like that. I'm going to put 2 and then a colon also. Please, I want you to make sure that there's a colon and there's a semicolon. A semicolon is used when we're talking about what columns, when we're trying to make a column vector. When you use a colon, you're saying, okay, I want you to skip through something like that, from one through this, or from one, you're going to be skipping two in between to what, to 20, like we'll have here. So you can see the outputs, okay, here, but we can visually see better when we go to our workspace and double click on that particular variable we declared. So this is one. When you skip two, you're going to have three. When you skip two, you're going to have five, and then everything. Now, because we're skipping two and we're falling on all the numbers, definitely we're not going to get to 20. But 20 is what is an even number. So we're going to stop at what, 19. I hope that is understandable. Okay, so another way to actually do this is by using a function called linspace. So this is the first function you're going to meet. Congratulations. So let's say, oh, well, it's not necessary, it's not really the main function. I think we saw sine and cos before now. So, but this is one function that will help you when you are trying to get matrices, or you're trying to, form a matrix, whether it's a vector or column matrix, or majorly used for vector matrix. So V5, for example, is going to be equal to, so this is lane space. So this is the function. And then we're going to be creating, let's say 1 to, let's say 1 and 10. Let's start with that for now. So if I'm to run this code, what we're expecting to be the output is going to be a 1 by 100. The function linspace in MATLAB creates um, evenly spaced numbers from the first argument you put to the what, and the second argument you input. So the first argument here is 1, and the second argument is what, is 10. So MATLAB is going to, using this function linspace, you are going to create 100 digits, 100 digits, but they have to be evenly spaced between 1 and 10. So let's run that. Good. And let's double click on V5. First of all, we have a 1 by what, 100 double, and then you can see this is 1 all the way to 10. Now we have different values in between them. Now these values are evenly spaced, meaning that they are evenly spaced. I think that's self-explanatory. So that is what the function linked space does for you. It creates, you can see, it's a very easy way to create a matrix. So what if you don't want it to be 100? What if you want it to be like maybe 10 or 20? You want numbers 1 to 10, but evenly spaced for just a 1 by 20 matrix instead, not a 1 by 100, but a 1 by 20. So we're going to put a comma, and then we're going to say 20, and then we run this. Good, we have a 1 by 20 matrix now. So let's check that out. A 1 by 20 matrix that starts from 1 and needs to end in what? 10. So instead of having 100 digits, we have compressed it to what, to 20 what digits. So I hope you have a clear understanding on vectors and columns, and also how to use the linspace function. I hope to see you in the next video.